from the November 2017 grade 12. Question 8. In the diagram, points A, B, D, and C lie on a circle. CE is parallel to AB with E on AD produced. Chords CB and AD intersect at F. D2 is equals to 50 degrees and C1 is equals to 15 degrees. 8.1. Calculate with reasons the size of A. So they are looking for that angle right there. A is equals to E because of alternating angles. And then D2 is equals to C1 plus E. Exterior angle of triangle is equals to the sum of the interior opposite angles. D2 is 50, C1 is 15 plus E. Therefore, E is equals to 35 degrees. And then we said E is equals to A. So this is because of alternating angles, because CE is parallel to AB. And then they want us to calculate C2. So the whole of angle A is equals to C2, which is equals to 35 degrees. And this is because angles on the same segment. 8.2. Prove with a reason that CF is a tangent to the circle passing through points C, D, and E. C, D, and E. So C2 must be equals to E. C2 is equals to E. They are both equals to A. Therefore, CF is a tangent to the circle passing through C, D, and E. And then we say the converse of the tan chord. Question 9. In the diagram, triangle ABC and ACD are drawn. F and G are points on sides AB and AC respectively, such that AF is 3x and FB is 2x, AG is 12y, and GC is 8y. HE and K are points on sides AD, such that GH is parallel to CK and GE is parallel to CD. 9.1. They want us to prove that FG is parallel to BC. So FG must be parallel to BC. If we can find that the ratio of the side is equals to the ratio of that side, then FG will be parallel to BC. So we will say AF over FB is equals to 3x over 2x, which is equals to 3 over 2. And then AF goes with AG, then FB goes with GC. So this is 12y over 8 y, which is equals to 3 over 2. Therefore, FG is parallel to BC. And then we'll say the converse of the proportionality theorem. 9.1.2. Prove that AH over HK is equals to AE over ED. So in triangle ACD, AG over GC is equals to, so AG goes with AH all over HK. So this is going to be AH all over HK. Line parallel to one side of triangle. And that line is GH parallel to CK. Also, AG over GC is equals to, so this is also equals to AE all over ED. E over ED. Line parallel to one side of triangle. And that line is GE parallel to CD. So as you can see, AH should be equals to that other. So this is going to be AH over HK, which is equals to AE over ED. They are both equals to AG over GC. Then 9.2. If it is further given that AH is 15 and ED is equals to 12, calculate the length of EK. Okay. So AG over GC is equals to, so we already know that AG over GC is equals to AH over HK. And then AG, that's 12y, and then GC is 8y. AH is 15 over HK. Therefore, HK is equals to 8 times 15 over 12. So I'm getting 10. And then I'm also going to do AG over GC is equals to AE over ED. And then AG, that's 12y over 8y. And then AE. For AE, so this is AE, which is 15 plus HE all over ED is 12. So this is 144 is equals to 8 times 15, that's 120, plus 8 HE is equals to 144, 20 divided by 8. So I'm getting 3. So this length here is 3. And then EK is simply just the difference of HK minus HE. So this is 10 minus 3, which is equals to 7. That's the length of EK. Question 10. In the diagram, W is a point on the circle with center O. V is a point on OW. Chord MN is drawn such that MV is equals to VN. If a line is drawn from the center to the midpoint of chord, so that means that V is perpendicular, OV is perpendicular to MN. The tangent at W meets OM produced at T, OM produced at T, and ON produced at S. So this is 90 degrees as well, because of the radius. This radius is perpendicular to the tangent. 10.1. Give a reason why OV is perpendicular to MN. So the line drawn from center to midpoint of chord. Then 10.2.1. Prove that MN is parallel to TS. So we need to prove that MN is parallel to TS. Well, first of all, OWT is equals to 90 degrees because the radius is perpendicular to the tangent. So this means that OWT is equals to OVM. So this means that MN is parallel to TS because of corresponding angles. We are forming an F there. This is 90, that's 90. So this must be parallel to that. 10.2.2. Prove that TMNS is a cyclic chord. Okay, so we still have those parallel lines there. So M1 is equals to N1 because this is a radius and that is a radius. So these two angles should be equal because of radii, the radii. And then but M1 is equals to angle T. So M1 is equals to angle T because of the F. This angle should be equals to that angle. Is equals to T because of corresponding angles. So this means that N1 should be equals to T. So this angle right here is equals to that angle. So it means that therefore TMNS is a cyclic quadrilateral because exterior angle of a cyclic quad is equal to the interior opposite angle. Then 10.2.3. So we need to prove that OS multiplied by MN is equals to 2ON W multiplied by WS. So what I tend to do with such questions, I know for the fact that there's a multiplication sign. I need to prove similar triangles, or it can be the proportionality theorem. And usually when you have multiplications like this, these two are most likely to be one of the two or a combination of both. And it's rarely the theorem of Pythagoras, because when you have the theorem of Pythagoras, you'll have a plus sign or maybe a minus sign somewhere. Okay, so OS, let me go and find the line OS. OS is right there. And then I'm going to look for MN. That's MN. And then ON. ON is right here. And then I'm going to look for WS. WS. So it means that I will work in triangle OWS and maybe in triangle, in that triangle or this one. I don't think it's triangle OMN, and this is simply because I don't have a 90 degrees there, because I will need to prove that the two triangles are similar. So if I choose OMN, I won't have the 90 degrees to match this. So I think it will be the other triangle. So I think it will be this triangle and not this one. So I will say in triangle OVN and triangle OWS. So O2 is equals to O2 because it is common. And then OVN is equals to OWS. They are both equals to 90 degrees. And then N1 is equals to OSW. Now you could say corresponding angles, because you know that MN is parallel to TS. So this means that triangle OVN is similar to triangle OWS because of the angle. So I'm going to create a ratio. This over this, that over that, and then that over that. So I will say OV over so this is OV over OW is equals to VN over WS, which is equals to ON over OS. Okay, I don't have any OV there, so it's most likely not the first ratio. VN I don't have, but I do have WS, and then I have ON as well, and I have OS as well. So VN over WS is equals to ON over OS, and then we just say similar triangles, and then I'm just going to multiply. So WS multiplied by ON is equals to OS multiplied by VN. This VN there is not there, so I need to find a way to eliminate the VN. And then out of nowhere I have a MN. So MN should be equals to MV plus VN. but MV is equals to Vn. So it means that Mn is equals to 2 times Vn. Therefore, Vn is equals to Mn over 2. So this is OS multiplied by Mn over 2, which is equals to Ws multiplied by On. And I'm just going to fix this. So I have OS multiplied by Mn, then the 2 On multiplied by Ws. So it's proven. And then this is a proof. And then question 11.2. In the diagram, BC is a diameter. So it means that this angle is 90 degrees. BC is a diameter of the circle. The tangent at point D on the circle meets CB produced at A. So this is a tangent, that is a chord. So this D2 must be equal to X because of the tan chord. CD is produced to E such that EA is perpendicular to AC and BD is drawn. Let C equals to X. 11.2.1a. Give a reason why D3 is equals to 90 degrees. That's an angle in the semicircle. B. ABDE is a cyclic quadrilateral. So I'm looking for A, B, so it's ABDE. ABDE. Well, it's because this angle is 90 and that is 90. So it's the exterior angle of cyclic quad is equal to the interior opposite angle. And then C, D2 is equals to X. Well, that's because of the tan chord. And then 11.2.2. So I need to prove that AD is equals to DE. I need to prove that AD is equals to AE. So if I can prove that this angle is equals to that angle, then they'll both be equal. Well, D1 plus D2 plus D3 is equal to 180 degrees, and these are angles on a straight line. And then this is D1 plus D2 is X, and then D3 is 90 degrees. Therefore, D1 is equals to 90 degrees minus X. And then in this triangle, in triangle AEC, angle A plus C plus E should be equals to 180 degrees. Sum of angles in a triangle. And then A is 90, this is X plus E. So E is equals to 90 degrees minus X. This implies that AD is equals to AE. Opposite angles equals to sides. And then B. I need to prove that triangle ADB and triangle ACD. So triangle ADB, triangle should be equals to ACD. So angle A2 is equals to angle A2 because it's common. And then we've said that D2 is equals to C because they are both equals to X. And then ADC should be equals to the B2. Then this is that angle of a triangle. This means that triangle ADB is similar to triangle ACD. Angle, 11.2.3. It is further given that BC is equals to 2AB, which is equals to R. So AB must be R so that BC can be equals to 2 times that. So this is 2R. Okay, and then prove that AD squared is equals to 3R squared. And then we just use AD. So I'm using this. AD over AC is equals to DB over CD, which is equals to AB over AD. So I am looking for AD. AC I do have, and then DB I don't have DB, but I do have AB, and I also have that. So AD over AC is equals to AB over AD. And then we just say similar triangles. So AD squared should be equals to AB multiplied by AC. AB, that's R, and then AC, that's 3R. I'm going to take that R, add it with the other one, so I get 3R. So this is 3R squared. And then B. Hence, prove that ADE is equilateral. So I need to prove that ADE is equilateral. Okay. So I know that this is R and that is 2R. And since AD squared is equals to 3R squared, this means that AD should be equals to R square root 3. And we did prove that AD is equals to AE. So this is R root 3, and that's R root 3. Okay. For an equilateral triangle, this must be 60, 60, 60. Or I just need to prove that this length right here is R root 3. If I can prove that these three angles are equal to 60 degrees, or if I can prove that ED is R root 3, then I would have proven. Okay, So in this triangle, this big triangle, I can find the value of x, or I can find that. But I'll calculate the value of x, since I know that d1 is 90 degrees minus x. That way, when I find d, I'll also find e. So in triangle EAC, the tan of C should be equals to EA over AC. So tan of x is equals to, this is r root 3, and that's 3r. This takes care of that. So x should be equals to, so this should be tan root 3 over 3. So I'm getting this to be 30 degrees. That's the value of x. And then d1 is equals to 90 degrees minus x. This is from here. So this is 90 minus 30, which is equals to 60 degrees. D1 is equals to E, which is equals to 60 degrees. So E plus D1 plus A1 equals to 180 degrees. So we can see that A1 is going to be equals to 60 degrees. Therefore, triangle ADE is equilateral.